Hi, welcome to STR8CHEM. My name is Nurfazilah. Today I'm going to teach you about electrochemistry. Here the question is about galvanic cell at standard conditions. Standard condition here means that the conditions of the cell is in 1 atm and the temperature is in 25 degrees Celsius, which is the room temperature. So here it also gives the cell notation for the galvanic cell. So this cell notation is what gonna help us on answering all the questions. Alright, so without further ado, let's move on to the first part of the questions. It asks to write the half reaction equations at both electrodes. We know that galvanic cell only have two electrodes, which is cathode and anode. So how we gonna identify the half reaction equations of cathode and anode? So here it gives a cell notation, right? Before that, I want to compare the cell notation to the real galvanic cell. So here is the galvanic cells. So how we gonna identify which is anode and cathode is by ABC terms. What I mean by ABC terms is, you can see at the most left of this galvanic cell is anode, which start with A, which is, we're gonna put it, means A, and then in the middle is a salt bridge and it indicates the B, and in the most right is cathode, which is start with C. So I believe you guys can see the pattern of ABC. So the same things we're going to apply in the cell notations, which is from the most left side, we're going to have this side as anode. Why? Because the symbol here, this symbol in the middle, referring to the salt bridge. So this most right side is the cathode. So how are we gonna write it? So I'm gonna put it like this. Put cathode and anode. So how to do? First we're gonna know what reaction happening in cathode. So just remember red cat, which is the reaction that happening in cathode is reduction, which means the reaction is gaining electrons. So when you gain electrons, it's gonna be like this. E2 plus 2E over here. We have that is the half reaction for cathode. And for anode, if reductions happening in cathode, obviously oxidation is what happening in anode, which means the reaction is losing electron. So the E gonna be in the right side like this. So here you go, the half reaction for both electrodes in the galvanic cells. So first, I believe that some of the students might be confused how to determine which of these electrodes they're gonna gain and loses electrons. So I have some tips on how to memorize which of these electrodes that gain or loses electrons. So you can see over here oxidations which happening in anode. So you can see we have O in oxidation. That means we are losing electrons. And of course, down here we have reduction. That's the only thing. And the opposite of losing electrons, we are actually gaining electrons or gaining electrons. Let me just put E. So that is the only way, the tips that I can give so that you can remember which one of the electrodes gonna gain or lose electrons. So oxidations, just remember there is O in oxidation, so means we're gonna lose electrons. And for reductions, we're gonna gain electrons. Both words don't have O. Alright, so that is for the first part. And the second part is, we look at here, the second part talks about it as to calculate E cell for the electrochemical systems. So this question is so simple. All we need to do is we need to know the equations. So these are the equations for E cell. E cell equals to E for cathode minus E for anode. So you can see here the questions already give the E naught for Fe 2 plus and Fe, and also the zinc. So all we need to do is just substitute the value here. We know that the cathode is Fe, the ferrum. So we need to put this, how we're going to do it. We must include the sign as well. Minus E for anode. Anode is zinc, so it's negative 0.76. Alright, so in that we're gonna get 0.32 volt. Don't forget to put plus or minus based on what you got in the calculator. If it's positive, then you need to write the positive sign, and if it's negative, you need to write the negative signs. Alright, that is the answer. So that's all for today. Thank you.